I'll be talking about motivation to learn by age, education, and literacy skills among working age adults in the USA. My name is Takashi Yamashita. I'm a faculty member of Sociology, Anthropology, and the Public Health Department at the University of Maryland, Baltimore County, US. It's UMBC. My co-authors are Tom Smith from Northern Illinois University, Shalini Sahu from UMBC, and Phyllis Cummins from Miami University. So just to give you some brief background, motivation to learn, lifelong learning is any form of learning or educational activities, and they are known to have economic benefits such as job security, higher pay, as well as social, cultural, and political participation, and well-being, such as physical health and mental health. However, in the United States, only about half of adults participate in any education or training. So there is a large space for improvement. And then we believe that based on previous studies and then our previous work, motivation to learn should be the first step to promote lifelong learning. Because without motivation to learn, no behaviors seeking education or training opportunities can be triggered. So the enhancing motivation to learn will ultimately promote lifelong learning behaviors. One of the challenges in motivation to learn research is how to assess motivation to learn. In the literature, particularly in the US literature, there are two predominantly used assessment tools. One is the SATS by Noe and Schmidt. The other one is MSLQ by Duncan and Makichi. These two assessment tools have been quite often used in the motivation to learn research. However, as far as our literature review goes, all of them either focused on case studies or small number of organizations such as schools or companies. So there are only limited number of studies used nationally representative data of adult population in terms of motivation to learn research. And our discussant, Professor Gorgeous' work, the PIAAC four-item motivation to learn construct is one of the few examples. So in this study, we addressed the following questions. How is motivation to learn distributed across subpopulations defined by age, gender, education level, and literacy in the US? In order to address this research question, we had to do two things. One is to check the validity of motivation to learn construct across subgroups of interest. Because if the measurement doesn't work for certain subgroups, we can't compare apple to apple. And the previous studies addressed some of the issues, validity issues across different groups. And the second step is to estimate the mean, basically the average motivation to learn for each subgroup, and to conduct a statistical test to see if which groups are more motivated than others. And here, I would like to talk a little bit about the commonly used method to get at this issue, and then move on to our study. So there's something like motivation to learn, we cannot directly observe. So we need to use theoretical propositions and looking at the relationship between unobserved latent construct and something that we can observe. So this is how the motivation to learn was modeled. And I think first presentation showed some of them. So I'm not going to get into too much details, but essentially we are using the theoretical proposition to get at unobserved latent motivation to learn construct based on the 4 survey items. The issue is this might work for general populations, but we don't know if this works for different subgroups. So in this slide, I just want to use simple example of men and women. And we often use what's called the invariance test. So to make sure that if this measurement model works for different groups, in this case, men and women. And then specifically, we use what's called a multi-group CFA or multi-group confirmatory factor analysis to make sure these are comparable. So the first step is what we call configural invariance. So what that means is that essentially the model specification, the theoretical model of relationship between latent motivation to learn construct and the 4 survey items. This model specification are the same for 2 groups, for example, men and women, right? So once we have empirical evidence to show that this shows invariance, then we can move on to the next step. The next step is what we call metric invariance. So this is equivalent to the regression coefficient or regression slope, right? So the relationship between latent motivation to learn construct and observed items. So that this is what we call factor loadings. The factor loading shows the degree of strength of relationship between these 2 things. And we compare the corresponding factor loadings and to make sure they are equivalent. So once we show metric invariance, we can move on to the final step of invariance test. That is to compare the intercept of different groups. So relationship between latent motivation to learn construct and observed survey item. You can think of the linear model of, consisting of intercept and the slope. So we need to check if intercepts are equivalent across these groups. So if we could provide empirical evidence to show these 3 things, configural invariance, metric invariance, and the scalar invariance. Now we have a justification to compare these 2 models and to compare apple to apple across different groups. So this invariance approach works very well when we have small number of groups. However, let's imagine that we need to compare many groups. Let's say 16 groups. So just simple calculation. If we are to do this comparison for 16 groups, the combination of that would be 120 pairwise comparisons. And if we are to compare every factor loading, every intercept, and then even every residuals or what we call measurement error, we may be looking at over 1,000 comparisons. And some of them are very likely that different, right? So it's going to be non-invariance. And whenever we observe non-invariance, we need to make some adjustment to the model. And after doing so many times, at the end of the comparisons, we might be looking at the very different models. So what I just described is what's called the exact approach, such as multi-group confirmatory factor analysis. So the model structure, intercept, and the factor loadings needs to be the same. There is a thing called a partial invariance. So some small percentage of non-invariance can be accepted for the group comparisons. But still there are some discussion going on about it. So in this study, what we adopted is what we call approximate approach, specifically the alignment optimization method. Alignment optimization method, which is actually a computer algorithm, is something that can estimate and compare the latent means, even with up to 25% of non-invariance across groups. So the advantage of this approach is even though some of the measurement model might not be exactly the same, but when it comes to mean comparisons, we can balance those out and then still make meaningful comparisons across average motivation to learn. I would like to describe alignment optimization method in a very simple way. So in 3 steps. The first step is to fit the configural model and then constrain the latent means to 0 and the latent variance to 1. And in the second step, estimate the intercepts and the factor loadings to minimize the non-invariance. so, using the simplicity functions. The simplicity function is essentially the sum of non-invariance. So if you could minimize the sum of non-invariance, that means you are minimizing the differences across these groups in terms of measurement models. And after finding the best combination of intercept and the factor loadings, the computer algorithm will find the latent means and variances and conduct a significance test so that we can compare which groups have higher motivation to learn than others. So essentially, this is a machine learning technique. If you wanted to sort of like give a good conceptual image, sort of like you are comparing the models and to find a good balance so that we can compare and contrast. We obtained the data from 2012, 14, 17 US PIAAC restricted use data. We obtained the data license from National Center for Education Statistics. We focused on general working age populations, age 25 to 65 years old. Our final sample size is a little over 8,000. We adopted that 4-item motivation to learn construct. And then in this presentation, I'm just going to focus on one set of subgroups defined by 2 literacy proficiency levels, middle to high versus low, and 4 age groups and the 2 gender groups. And this tree diagram shows the detailed subgroup classifications. So each group gets numbers from 1 to 16. And we used the alignment optimization algorithm implemented in the M+ version 8. And this is the result, and it's sort of hard to see what that tells us. So I'd like to highlight a few things. From the left column, it shows the ranking. So number 1 means the highly motivated. The number 16, the least motivated. The second column shows the group number. Third column shows group description. And the fourth column shows the factor mean. So this is the estimated average motivation to learn. Then also the right column shows the result from the significance test. So these numbers shows groups with significantly smaller factor means. If you could look at top 4 groups, they are consistently young adults with high literacy skills. And if you look at the bottom 4, they are basically the older working age adults with low literacy skills. So there seems to be some sort of patterns here. And also, if you look at the most motivated group, the young men with high literacy skills, they seems to have significantly higher motivation to learn than most other groups. So is that all about age and the literacy skills? That may not be the case. So the ranked number 5, young men with lower literacy skills, they are still highly motivated. So it's not all about age and the literacy, but perhaps there are some interactions going on here. So just to sum up, this study analyzed the PIAAC data to estimate the mean of latent motivation to learn construct, which promotes lifelong learning using alignment optimization method and algorithm of automated exploratory multi-group confirmatory factor analysis. I just kind of wanted to use lots of acronyms to summarize this study in one sentence. And alignment optimization method can be useful to compare latent means across many subgroups. Just overall, younger age and higher literacy proficiency seems to predict higher motivation to learn, but that doesn't tell all the story. So there might be some variations and the possible interactions. So since we used the nationally representative data, so this national profile of motivation to learn by subgroups may be useful for education and the lifelong learning policy discussions. For example, we know that top 4 groups, the young adults with high literacy skills. So if we could identify this subgroup in any organizations, perhaps all we need to do is to provide more education and training opportunities, or make them accessible to younger adults so that they might respond to this type of intervention or policy change as well. At the same time, the bottom 4 groups, the older working age adults with low literacy skills, they may need different approaches. For instance, they may need to be motivated first, right? They may need to realize that certain things could benefit their lives. They may need some basic skill training. So if they could improve literacy skills or other basic skills, digital skills, it might lead to higher level of learning, and they might find the joy in such learning. So the possibility is unlimited, but this first step to develop national profile of motivation to learn by subgroups may be a useful piece of information for future discussions. So I'd like to acknowledge that this study was partially funded by IES, Institute of Education Sciences, US Department of Education, and the use of PIAAC restricted use data file data was reviewed and approved by the IES data disclosure team. And we would like to thank Ms. Maya Punksinger and Ms. Donette Narin for their constructive feedback on this project. That's all I have for you today. Thank you very much for listening.